All right, so you have your three sum and difference. They're called the sum and difference identities up at the top. The first one, sine, cosine, tangent, right? I'm going to pull this out so we have this for our reference here. All right, so that very first problem, it says the sine of 44 times the cosine of 1 plus the cosine of 44 times the sine of 1. That used the sine, cosine, or tangent identity. Which identity did it use? A sine, cosine, or tangent?
Sine.
It used the sine. How do we know? Because we have a sine, cosine, right? Sine, cosine, cosine, sine. It's set up exactly the same. What was angle A in this case? 44. What was angle B? 1. And was angle A plus angle B, or was it angle A minus angle B? There's a positive between these, so the positive is the one on the top, right? So you have to go with the one on the top. They were being added together. So this is another way to say the sine of 45. 44 plus 1 is 45. What is the sine of 45? Square root of 2 over 2. So this is an identity. If you see something written out like that, sine 44, cosine 1 plus, and then the reverse, that is the same value as the sine of 45, and the sine of 45 is the square root of 2 over 2. All right, the next one, number 2, is this sine, cosine, or tangent to sum or difference identities? This one is a cosine because the cosines are together, right? You have cosine, cosine, then sine, sine. What is angle A? 332. What's angle B? 152. Is this being added or subtracted, those two angles? In here you have a plus, which means if you have a plus, you're using the one on the bottom, right? So then you're technically subtracting them. So 332 minus 152. What is 332 minus 152? 180. So this is the equivalent of saying the cosine of 180. And what is the cosine of 180? Negative 1. So this crazy value right here, if you were to type this in your calculator in degree mode, it would spit out negative 1. Be like, negative 1, here you go. Oh. Yeah. All right, next one, sine, cosine, or tangent for number 3? Tangent. If it has all tangents, it's from the tangent. All right, and then angle A is 116, angle B 64, and then you have to decide, is it going to be added or subtracted based off the signs. We have a plus on the top and a minus on the bottom, so based off the plus or minuses, it's going to be plus or minus the angles. They're adding together, yes. So 116 plus 64. Also 180. So this is another way of saying the tangent of 180. What's the tangent of 180? 0 or undefined? Sine over cosine, right? And sine at 180 is 0. So it's 0 over negative 1, so 0. All right, getting into the radians now. We have cosine 11 pi over 18 and cosine 19 pi over 18 minus sine and then another sine. So is this a sine, cosine, or tangent identity here? This is a cosine. And then is this cosine, the two angles that we have, 11 pi over 18 and 19 pi over 18, are they being added or subtracted? They're going to be added. How do we know? Because there's a subtraction in between them, right? And if you're looking at the cosine, that's the one where it's reversed. So since there's a subtraction in between, there will be a addition between the two angles. So inside your cosine, it's 11 pi over 18 plus 19 pi over 18. And what happens when you add 11 pi over 18 plus 19 pi over 18? What do you get?
30 pi over 18.
30 pi over 18, right? 11 plus 19, they already have common denominators. So 30 pi over 18. And we need the cosine of 30 pi over 18, or we could try to simplify this first. 30 over 18. Did it simplify?
Yes.
They both have a 6 in them, right? So this is the cosine of divide them both by 6. You'll end up with 5 pi over 3, and that is a number on our unit circle, right? 5 pi over 3. Down here, cosine is a half. So this crazy mess right here is literally equal to 1/2. 1/2. Oops, my bad. All right, let's keep going. We have sine and cosine together, and then cosine and sine. And so is that the sine or cosine or tangent identity we're going to use for that next one? The sine. And that sine identity, are we going to add or subtract these two angles? This has a minus between them, right? And for this sine identity, if you go back up, the minus is the bottom, so you have to use the symbol on the bottom, so you're going to subtract these angles. So the ones that we subtract, because subtraction, the order matters, right? So you need the angle A and angle B, you got to be careful. So this is 7 pi over 18, right? Minus 5 pi over 36. And we got to subtract those angles together to one angle, and then we can evaluate it. So in order to subtract something over 18 and something over 36, you have to get a common denominator. So we'll take the 18 and turn it into a 36, yes? By turning the 7 into a 14. So 14 pi over 36, and then minus 5 pi over 36. 14 minus 5 is 9. So this is the sine of 9 pi over 36, which simplifies to pi over 4. So it's just the sine of pi over 4, which is just the square root of 2 over 2. All right, you want to try number 6 on your own?
Okay.
Give it a shot. See what you come up with. All right, so when I added them together, you had to get common denominator still again, right? So you wanted to change the first one to over 36. So 14 pi over 36. When you add them together, you get 45 pi over 36. And they both simplify with a 9, right? So 5 pi over 4. And so what is the tangent of 5 pi over 4? 1. By the way, the tangent of anything over 4 is either 1 or negative 1, right? And 5 pi over 4 is in Q3, and in Q3, sine and cosine are both negative, so that makes the tangent positive. All right, we're going to come back to number 7, so we're going to jump to the next page, so remind me to come back, all right, at the end of class. Okay, so this is really funny. So I converted this to a Google Doc, and apparently every time I put a trig function, it put a second trig function in its place. So it says cosine 75. It's really just saying cosine of 75, and that's what it says on your paper, just one cosine, right? Yeah, so pretend like whatever's going on here is not happening. I don't know if that was a weird mess up on the computer's part. All right. So cosine of 75. Is 75 an angle on the unit circle that we're used to using?
No.
It is not, right? So here's where these identities become really, really useful. 75 degrees can be made up by using a couple of our nice angles, can it? So think about 75. What angles that are really nice that we do know from the unit circle could we use to help us find the cosine of 75? 30 and 45. And what happens with them? You can add them together. So the cosine of 75 is the same as saying that the cosine of 30 plus 45, or you can say 45 plus 30. Is that the only way to get 75 using the unit circle? 75? Could you do 135 minus 60? That would get you 75, right? You could do something crazy. You could do like 225 minus 150, right? So whatever you pick, and there's tons of options, whatever you pick, either have to add or subtract to get the number that you're looking for. All right, so 30 and 45 are definitely the most obvious, I think, for sure. But that's not the only set. So you might do something, and I might have picked a different set, and we might have different work, but we'll get the same answer. Does that make sense? So just because we picked one doesn't mean that's the only one. All right, so this is the cosine of 30 plus 45. So we're going to use the cosine identity, and we're going to use the one with the plus. So this starts off with cosine of one angle and cosine of the other angle. So this will be equal to the cosine of 30 times the cosine of 45. And then are we going to use plus or minus for this cosine? We're going to use the minus, right? So we had to use the plus because we wrote 30 plus 45. So since we picked a plus, we'll use the minus. And it's minus the sine of one angle times the sine of the other angle. And you're going to evaluate this. So you're actually going to fill in now what is the cosine of 30, the cosine of 45, and we're going to simplify this down as best we can, all right? So using unit circle over there, or what you know, right, because we're pretty good at the unit circle now, cosine of 30, what is that equal to? Square root of 3 over 2 times the cosine of 45. What's the cosine of 45? Square root of 2 over 2 minus, what's the sine of 30? 1/2. And then the sine of 45? Square root of 2 over 2. And we're going to simplify this as best we can, all right? The first set multiplication we have is square root of 3 over 2 times square root of 2 over 2. So what does that turn into? Square root of 3 over 2 times square root of 2 over 2. This first piece right here. What do you think? Square root of 6 over 4? Numbers inside square roots can multiply with other numbers inside square roots. So 2 times 3 is 6, and that lives in a square root. And then when you're multiplying fractions and the denominator, 2 times 2 is 4. The second set, 1/2 times the square root of 2 over 2. Square root of 2 over 4. And that has a minus in front of it. Miss Bird. Okay. Colin. Have a good one. All right, and then can we put these two fractions together?
Yes.
Yeah, they have a common denominator. So common denominator will be over 4. In the numerator, what will we see? Can you put square root of 6 minus square root of 2 together at all? Those like terms, can put them together. Nope. It's just square root of 6 minus square root of 2 all over 4. So this is the best we can do in terms of simplifying our answer down. So that is the exact value of the cosine of 75. So if we went to our unit circle and put 75 degrees on here, its x-coordinate, its cosine, right? Cosine is the x-coordinate, would be the value of square root of 6 minus square root of 2 all over 4. That would be the cosine of 75 degrees. Kind of unique, right? Kind of different. Yeah, so pretty much what we're doing is we're finding values of these trig functions that aren't in the normal unit circle. All right, by the way, if you know the cosine of 75, could you figure out the secant?
Yep.
Yeah, you would take your answer and flip it, right? Reciprocate it? Exactly. Sorry. Okay, let's try the next one. Sine of 345. So you can either create an addition or a subtraction problem for this 345, and you can pick any combination that you want as long as it will make a 345, right?
Mm-hmm.
All right. 345. Lots of options. Yeah. Somebody give me a option. Any option to get 345. Now remember, you want it to be on the actual unit circle, right? So you don't want to pick like 340 and 5 because that's not very helpful because we don't know those. So 345. Say that again? 135 and 210. And did you add or subtract? 135 and 210. That's an option. What's another option? Give me another one. 300 and 45. 345. Yeah, you can go with that option. Give me another option.
339.
The minus is kind of hard here because you'd have to get into more than a 360, right, before you could minus. So minus wouldn't really work very well. I thought of 315 and 30.
Mm-hmm.
That would work out well too, right? 315 and 30.
Mm-hmm.
Any others? That's pretty good, right? All right. Well, we'll roll with the first one I heard, the 135 and the 210, all right? All right. If you do one of the other ones, though, you should get the exact same answer. So let's see what we have. This is the sine, so we're going to use the sine identity. So this will be the sine of 135, cosine of 210, and then we will use plus or minus. It's going to be a plus. So we have a plus b inside the sine, so we're going to use the plus for the other one. So plus, and this will be the cosine of 135 sine of 210. So essentially they reverse, right? Sine, cosine, and then they reverse, so then it's cosine, sine. So there is some patterns to these handy-dandy formulas, identities. All right, and then once you have that, you're ready to go ahead and evaluate. What is the sine of 135? Square root of 2 over 2? Positive or negative? Positive. Cosine of 210. Negative square root of 3 over 2. Okay, and then I have a plus sign. Cosine of 135. Negative square root of 3 over 2. Or sorry, square root of 2 over 2, right?
Yeah.
My bad. That didn't look right. All right. And then the sine of 210? Negative 1/2. And you're going to go ahead and multiply and simplify as best you can. So square root of 2 over 2 times a negative square root of 3 over 2. In the numerator, when you multiply those together, what do you get in the numerator?
Yep.
Negative square root of 6 over 4. Over 4, right? Over 4. 2 times 2 is 4. And then when we multiply the second set, what are we going to get in the numerators? That's going to be a positive, right? Negative times negative is positive. And then with the plus sign, this will still be a plus square root of 2. And then over 4. And you can put these together. Negative square root of 6 plus the square root of 2 all over 4. By the way, does that look like the last answer? There's only one small difference in the numerator, where the minus lives, right?
Yeah.
So in the first one, the minus was with the negative, or with the square root of 2, and the second one is with the square root of 6. So when you're doing these sines and cosines, your answers are going to look very similar. And we would expect that to happen, okay? Definitely expecting that to happen. Because there's only so many ways you can multiply square root of 3 times the square root of 2 and 1/2 times the square root of 2, right? So there's only so many options that you can have. So you're going to start to see some patterns emerge, okay? All right. You ready for this tangent? Oh, this is the tangent of negative 105. So we need ways to get negative 105 using angles on the unit circle, negative 105. By the way, if it ends in a 5, you're probably going to have to use like a 45, right? Or a 135, something with a 5. Okay. But I got to get negative 105. Yeah. 30 minus 135. That will get us negative 105, won't it? All right, give me another option. We're going to roll with this one when we do the problem, but give me some more options for negative 105. 210 minus, which one? Sorry. 315. 210 minus 315, that will also get you negative 105, yep. Other options? Sorry, say it again. Oh, super close. Not 150 minus 45 because that's a positive, right? But throw it in reverse. 45 minus 150. By the way, that's the one that jumped out in my mind. 45 minus 150, so that's another one. Technically, could you do like negative 45 minus 60? Could you figure out these trig functions for a negative 45? You can, can't you? Right? That is a possibility. So if you wanted to use negative 45, you could. Just know that negative 45 is the same as positive 315. So yeah, you're not just stuck to the positives. You could also look at some negatives. It might make it a little bit more complicated, but you have tons of options, yes? Tons of options. All right, so let's roll with this tangent. 30 minus 135. All right, so for the tangent, we start with the tangent of A. Now you have to be careful, right? Because we have a subtraction going on. We got to make sure everything's in the right order. So the first angle is 30, so A is 30. Will this be a plus or minus the tangent of 135? Plus or minus? It will be a minus. So since we have a minus in our tangent, looking at our function, since the minus is on the bottom, you use the one on the bottom, right? So minus tangent of 135 over 1 plus or minus? Plus. And then this is the tangent of 30 times the tangent of 135. All right, let's go ahead and start evaluating. We need the tangent of 30. So go to angle 30. We need its tangent. By the way, everything with tangents is just that much harder, right? If it was sine or cosine, it's just one of the values, right? Just pull it. But tangent of 135 would be 1/2 over square root of 3 over 2. So square root of 3 over 3 minus the tangent of 135. -1. So it's minus -1. So is everybody okay if we change that to a plus? Okay. And then it's on the bottom, 1 minus tangent of 30 again, which we said was square root of 3 over 3. And then times by -1. All right. So what do we have? On the top, square root of 3 over 3 plus 1. On the bottom, we're going to have 1. And then these get multiplied, right? And it's a negative and a negative, so that'll turn into a positive. Square root of 3 over 3. Say that again, I'm sorry. This minus one? This one? Yeah, and that minus is built in from the equation. So because we used the two angles being added, no, you're right. Yeah, I see what you're saying. Ooh, good call. So here's what happened. We were using the subtract, right? So we used the subtract, and so we should have used the add. So then this is actually not plus, but minus, right? Did everybody see what happened there? What I had messed up? I had put the wrong sign here because I had put the wrong sign from the minus plus at the bottom. I had put the minus when it was really a plus. Thank you for correcting me on that. All right. It looks pretty good, but technically you can simplify this, can't you?
Yeah.
So you have fractions and fractions, and we never like to leave fractions and fractions, right? All right, so how do I simplify some fractions and fractions?
I'm checking the English and the type English.
Yeah, you're going to want to reciprocate the bottom, right? But you can't flip and multiply, reciprocate the bottom until you get one fraction in the bottom. You also shouldn't do it until you get one fraction in the numerator either, right? So we need to change those ones so that they have a common denominator. We can put them together. So the 1 should become 3 over 3's. So what we really have is the square root of 3 plus 3 all over 3. That's your numerator. And then the denominator would be 3 minus the square root of 3 all over 3. And now you're good to flip and multiply. So this denominator flips over, so 3 on the top and 3 minus the square root of 3 on the bottom. And then what's going to happen on the multiply? What happens on that multiply? Flipped and multiplied. What's going to happen on the multiplication? This 3 and this 3 will, yeah, there's a divide by 3 and a times by 3. So those will simplify. So a better simplified version is the square root of 3 plus 3 all over 3 minus the square root of 3. And that's just a lot of 3's, isn't it? So just like before, everything with tangent is harder, right? Everything with tangent is harder. All right, what questions do we have? We've only been working degrees so far, yes? Any questions on any of those degrees? I know the tangent one, definitely simplifying at the end, a little bit more frustrating than the sines cosines. Any questions before we hit those degrees? Very good. Questions? All right, I'm going to erase this so I have plenty of space. So the harder part with radians is it's not going to be as easy to figure out what adds and subtracts. Trust me, it's not. Because it's a fraction, right? And so in order to figure out how to get a pi over 12, you have to figure out what fractions either add or subtract to make pi over 12. And that's truly what makes this harder. So for sine of pi over 12, remember that's 1 pi over 12, right? So we need to figure out what two angles in radians either add or subtract to get pi over 12. So since it's 1 pi over 12, should we add or should we subtract? You're only getting 1 pi over 12. You're probably going to want to subtract, right? So most likely we're going to use a subtraction here. To get a denominator of 12, and we were subtracting two things together, so they had to have common denominators, what things on our unit circle might make a denominator of 12 pretty easily? What was that? 4 and 6 could both make 12s, right? So 4 can easily turn into a 12 by doing times 3. And 6 can easily turn into a 12 by doing times 2. 3 can easily turn into a 12 by doing times 4, right? And so you almost kind of want to pick and choose accordingly. So where do you want to start? Because this might be a little guess and check, try to figure out what's going on to get this pi over 12. So most likely we're going to want to pick maybe like a pi over 4.
Yeah, I think pi over 4.
Pi over 4. So I'm just going to throw this up here. Pi over 4 is what over 12? 3 pi over 12? Okay. And then we need to get something else that would have a 2 pi on the top, yeah? Because if you had a 2 pi on the top, then you could subtract and get 1 pi. So what's another one that could give me a 2 pi on the top over 12?
We don't have pie, but we got snack cart.
Hey, we got pie. We have plenty of pie up here.
Okay.
So much pie going on, I promise. All right, so what you're going to want to use, right, is pi over 4, this one, subtracted this one, and we said that simplified was pi over 6. All right. So you all finish, now that we know the radian angles, finish away and see if we'll get the same answer at the end. All right, here's what I got. Square root of 6 minus square root of 2 all over 4. By the way, if it's sine or cosine, you kind of expect it to look similar, right? To have like a square root of 6, a square root of 2, and over 4. It doesn't mean they're all like that, right? But you kind of expect them to be similar in nature. All right, how'd you do? I think with radians, once you get the hang of the actual like formulas themselves, the identities, the hardest part with the radians is going to be figuring out what got added or what got subtracted, right? Definitely the hardest part. By the way, since you have your calculator, you can always use your calculator, right? So don't put in any of the pi's. Never put in a pi into your calculator to try to figure out a radian of some sort, because it's going to use the actual version of pi, so it's going to just turn everything into decimals, which is not helpful whatsoever. But you could do 1 over 4 minus 1 over 6. Type in your calculator real fast. Just humor me. 1 over 4 minus 1 over 6. You're going to get a decimal. Hit math, enter, and it will change it back into a fraction. And the fraction that it spits out is 1 over 12. So you can always use your calculator to double check that you do in fact have the right one. So if you weren't sure if it was like maybe a pi over 4, a pi over 3, or what was going on, right? You can always use it. You can always add the two fractions together, subtract them in reverse until you get what you are looking for, okay? Now, taking an approach that has like some logic behind it could get you those angles faster than just like, hey, I'm just going to pick random angles. All right, so the next one, we have the cosine of 7 pi over 12. By the way, you're going to see a lot of over 12s. So 7 pi over 12. So to get 7 pi over 12, do you think we're going to want to add or subtract? Most likely, probably add. You could get there by subtracting, just throwing that out there. And 7 pi, when I think of 7, what numbers do you think of getting added together? 3 and 4. So I may be thinking a pi over 3 and a pi over 4. So you can always just throw it in your calculator or just kind of like think right to yourself. Pi over 3, that's 4 pi over 12. Pi over 4, that's 3 pi over 12. And if you add them together, you'll get 7 pi over 12. So it is pi over 3 and pi over 4 being added together. And you can use your calculator to help you out with that too if you need. But it might be easier to just take a systematic approach in terms of like, okay, this is over 12. Ooh, 7. 7's 3 and 4 together. All right, I'm going to pause here and I'm going to let you take the next step on applying the actual identity itself. By the way, I'd expect to see maybe a square root of 2, square root of 6, something over 4, right? Mm-hmm. Plus or minus is kind of, you just don't know where the minuses and the positives live on this. So I ended up with square root of 2 minus square root of 6, all over 4. Yes, no, maybe, how'd it go? Okay. Was it pretty good? Any questions? All right, you ready for another tangent? Tangents are the worst, aren't they? I think so, personally. All right, so this is tangent of 5 pi over 12. You're going to see a lot of over 12s. on these adding and subtracting. So 5 pi over 12. So when you think about the number 5 in terms of either adding or subtracting, think about what got added or subtracted to get a 5. The one that jumps out to me is 2 and 3, right? 2 and 3 add to get 5. And so I'm thinking maybe something with a 2 and a 3. And so if we can do 2 pi over 12 plus 3 pi over 12, that would give us our 5 pi over 12, right? And 2 over 12 is pi over 6, and 3 over 12 is pi over 4. So I know I can use pi over 6 and pi over 4. And it doesn't matter if you do pi over 4 first or pi over 6 first, right? Because you're just adding them together. If you were subtracting, then you'd have to be careful, right? And then also, if you struggle, you can always use the fraction buttons on your calculator, right? Never put in the actual pies because it's just going to change it all to decimals. Then it won't ever change it back to a fraction. But you can use that to try to help you get those fractions as well, all right? All right. I'll give you a head start on this one too. Go for it. Let's see what you come up with. Remember, tangent's harder, so give yourself a little bit of a break if you get stuck on this. Everything with tangent's harder, for sure. All right, when you're ready, you can check and see what I did on the board. I didn't show all the work for the common denominator, flip and multiply, because you're going to see that that tends to be the same general pattern every time. Those ones turns to 3 over 3s, and then the over 3s are going to simplify, so it's whatever's left in the numerators, right? You'll have the numerator at the top over the numerator of the denominator. Numerator at the bottom, I guess. Another way to say that. Do y'all want to see a way you can use your calculator to check to see if you did it right? All right, so first of all, tangent of 5 pi over 12. You can have your calculator calculate that value, but it'll give it to you as a decimal. Now make sure you hit mode and you're saying, hey, calculator, I want you to be in radians and not degrees, right? If we were going to check maybe the problem, one of these ones up here, you would want your calculator to be in degrees, right? So be careful. So everybody hit mode, radians, make sure you're in your radians, and then you can just hit second quit. It'll take you out of the mode. And type in tangent, just regular tangent, and then put in 5 pi over 12. And you should hit enter, get a decimal, right? What is this decimal that you get? Right? 1.038, is that what you said? 308? 308, 1.308. Okay, and so this value right here, whatever it is in your calculator, should be the same as this value that you get at the end. So you can put in a fraction. Do you remember how to put in a fraction? Alpha y equals, so hit alpha, and then the y equals button up at the very, very top. And when you hit enter, it'll put in a nice big fraction into your calculator. Type in this on the top and then this in the bottom. Make sure that you end the square root, right? So don't type in square root of 3 plus 3 because it'll do square root of 6, and that's not what that is. Make sure you type in square root of 3, hit the over button to get out of the square root, and then plus 3. And then put 3 over or 3 minus square root of 3 on the bottom. And when you hit enter, if you have simplified this completely correctly, you should get this number. No? No? Are we close? You got what? 3.736? 3.732? For this and this? For a tangent of 5 pi over 12, you got that 3 number as well? Oh, so our tangent of 5 pi over 12? Make sure you're in radians, right? Tangent 5 pi over 12. Yeah, I get this number. This one here, not this. That's all right. No worries. So both of them are equal to this decimal, right? And it keeps going. So because we know they're both equal to that decimal, then we know that we are good. We've simplified it correctly. Now, just so you know, if on the test or on a quiz I give you tangent of 5 pi over 12, am I going to accept 3.732 as an answer? No, I'm not. The whole point is to get the exact value using some of these identities, right? So it's kind of like, hey, we have more identities. Now we can use them to find other trig and functions. By the way, if you wanted cotangent, all you'd have to do is flip it, right? You just have to flip it around. So all of those things still apply. We're still talking trig functions. We're just now talking ones that don't live on the unit circle themselves. All right, we have to go backwards, yes? As promised, back to number 7. Down at the bottom. All right, and this one's kind of unique because they give you a bunch of information, all right? So they say, hey, the cosecant of alpha, that's a Greek letter alpha, standing for an angle, is 13 over 5. And it says that alpha is between pi over 2 and pi. So what quadrant does that put alpha in? Pi over 2 and pi, where does that live? That's quadrant 2, right? So let's take a look at what is happening here. I'm going to give myself a little bit more space. So ignore all this. So if I have a triangle in quadrant 2, this would be my alpha. And cosecant is what over what? 13 over 5 is something over something. Cosecant is what over what? Hypotenuse. So 13 over opposite, because it's the reciprocal of sine, and sine is opposite over hypotenuse. So that one's 5. So because it is a right triangle and we know those two sides, could we figure out the last side? Yeah, 13, 5 something 13. 5, 8, 13? 12, 5, 12, 13? Pythagorean theorem if you don't remember, but it is a 5, 12, 13. And by the way, since we're in Q2, technically that 12 is a negative x, right? Negative x, q2. And so here's all the information you need to know about alpha. Could you find sine of alpha? Could you find cosine of alpha? Tangent of alpha? The other three of alpha? Yeah, you can find all the alpha trig functions now, right? All right, so same things happening over here with this other Greek letter, and that's the Greek letter beta. It looks like a capital B, but it has like a little tail at the bottom. And it says that tangent of beta is negative 3 over 4, and that beta is in between 3 pi over 2 and pi over, or 2 pi. So where does that put beta? What quadrant? Q4. Q4. So if you draw a triangle in Q4, it's going to look like that, isn't it? Here's your 90. So here's your beta angle right there. And tangent is what over what? Opposite over adjacent, and it is a negative 3 over 4, and that's because the opposite is a y value that goes down, so it's a negative 3. What does that make the hypotenuse? 5, and that is positive. Your hypotenuse are always positive. Positive 5. 3, 4, 5, right? 3, 4, 5 triangles. That's like all the way back to day 1. 3, 4, 5, 5, 12, 13s. All right, and so what we're going to do is we're going to find sine, cosine, tangent of all of these things. So the sine of alpha minus beta, well, this is an identity. We can use the identities. And so you're going to use the sine identity. So this would be the sine of alpha times the cosine of beta. And since you have a minus, you're also going to use a minus, right? Because sine is the same. And then what's next? We'll have cosine of alpha, sine of beta. And you can find all of these trig functions here using the two handy-dandy triangles. So sine of alpha, if you go to alpha, sine would be 5 over 13. Times the cosine of beta. So you have to go to the beta triangle. Cosine of beta would be 4 over 5. And then minus, and then we're back to alpha. This time we need the cosine of alpha. Cosine of alpha is negative 12 over 13. By the way, if there's a negative, you can either just, negative 12 over 13, or if you wanted to make those two negatives, make it a positive, anything like that. However you want to put those signs together is fine. And then last but not least, the sine of beta. So here's beta. Sine would be negative 3 over 5. Put it all together, and you get the value for sine of alpha minus beta. And I will let you use your handy-dandy calculators. So however you want to calculate that, go for it. You can do a bunch of fractions, multiply together. Don't forget there's a difference between a minus sign and a negative, right? They make a big difference in the calculation. If you accidentally hit the negative sign when you're supposed to hit minus, your calculator will turn it into multiply by. And then you're not adding or subtracting at all. Oh, you got? Thanks. When I threw it all in my handy-dandy calculator, I ended up with negative 16 over 65. Yes? All right. We're pretty close to the end of class. So do you kind of understand how you would do the other two?
Yeah.
Yeah,
Yes.
for the most part? Okay.
They do the same thing like the previous one.
Same thing, but for cosine, you're going to use the cosine formula. For tangent, you would use the tangent formula, and you just have to find cosines and tangents accordingly, right? All right. So in terms of your assignment on Friday, you have an extra day than my other pre-cal class. Does that make sense? So I didn't see them at all today. So you guys are going to be like one day ahead. So on Friday, you'll have the entire block on Friday to finish any homework assignments / work on any of the assignments here at the beginning. Okay. So you kind of have this like bonus day, which is kind of nice, which worked out perfectly, right? So technically your assignment, what I want you to do is I do want you to finish these two. And then the actual like homework assignment is page 3 and page 4. Now you don't have to have it done for tomorrow because you will have time on Friday in class where you can work and check answers and ask questions, okay? So what we'll do is we'll do sum and difference today. Tomorrow we're going to talk double angles. And those ones are a lot easier, by the way. And then on Thursday we're going to talk half angles. So we're going to say, hey, what happens when you double the angle or cut it in half, and we'll have some formulas for those. And then on Friday, you can work on any of the homework up until for those 3 lessons, okay? So if you want to get a head start, absolutely. If you just want to wait till Friday, that's fine too. So completely up to you, all right?